n equals 1. Negative 1 raised to n times x raised to n over n raised to 2. So first, we need to apply the ratio test. So limit n approach infinity u n is 1 5 13 so limit and approach to infinity so equals to 1 raised to n plus 1 times x raised to n plus 1 over n plus 1 raised to 2 divided by negative 1 raised to n times x raised to n over n raised to 2. So we can remove the negative 1 raised to n plus 1 and negative 1 raised to n. So equals to the limit of n plus infinity of x raised to n plus 1 over n plus 1 raised to 2 times n raised to 2 over x raised to n. So this will equals to x raised to n plus 1 over x raised to n. N raised to 2 over n plus 1 raised to 2. So this will equals to limit n approach to infinity of absolute x raised to n plus 1 minus n times absolute n over n plus 1 raised to 2. So limit and approach to infinity x. So I will need sometimes n plus 1 over n plus 1 minus 1 over n plus 1. So this will be equals to absolute x and 1 minus 0 is to 2. So this will be equals to absolute x. So the series converges when limit is less than 1. So therefore absolute x is less than 1. So the intercept for the interval convergent is this will be equals to negative 1 to positive 1. And for the radius convergence, so let's have 1 over 2. So this will be equals to 1. So the radius is equals to 1. So now let's move to Taylor series. So say we are looking at this power expansion. So 0 to infinity of a sub n quantity of x minus c raised to the n power. So we can describe this with a function, but we may want to solve for the coefficient. So f of x is equals to a sub 0 plus a sub 1 of x minus c plus a sub 2 of x minus c raised to 2 plus a sub 3 times x minus c raised to 3, and so on. So it actually won't be as tricky as you think, that given the different x minus c in each of these terms, so if we find the f of c, so all of these binomials become 0. Become 0. Here. And therefore all of this term will become will equals to 0. So will be equals to 0. So this will be equals to 0, or except for a sub 0. So now, so the first coefficient down. So then, how do we get the next one? So this is where differentiation comes. So let's say we take the derivative of this function. So for a1. So a sub 0 will go away, so since the derivative of any constant is 0. So then for the second term, x minus c will go away, leaving a1 to be clear. So if we were to be distributed before taking the derivative, we will get a sub 1 times x minus a sub 1 times c. And since a sub 1 is just a number that will go away, so a sub 1 times x will become a sub 1. A sub 1. So for the other terms, we will use the chain rule, starting with this one. So a sub 2, sub 1. So this will be equals to so 2 comes down. Here leaving an exponent of 1, and then we multiply by the derivative of what's inside, which will just be 1. So we'll get 2 and a sub 2 times x minus c. So the second part of the chain rule will always be 1. So we can just do the part with the exponent. So here. So 3 comes down here and the exponent become 2. And 4 comes down and the exponent become 3. So with this expression, which represent the first derivative of the function, if we plug in c, all of this will disappear except for the original. Just like the original function. So now, so the only thing left is a sub 1. So f prime of a is equals to f prime of c. So this will be the derivative of f evaluated at c equals to a1. So let's go back to the expression for the first derivative and take the derivative again. So it is 282. So C1, A1 goes away and this term become 2A2. Then we have, so 3 times 2, so this will become 6A3 times the quantity of x minus c. Plus 4 times 3, so equals to 12. 12A4 times the quantity of x minus c squared, and so on. So plug in A for x. We'll isolate the 2A2 term. So this will be equals to f double prime of c is equals to 2A2, or a sub 2 is equals to f double prime of c over 2. So taking the third derivative and plug in c will give us a f prime of c is equals to 6A3 plus 12 times 2 is 24 C4 times quantity of x minus c. So this will be equals to f prime of, so f prime c. Also, this will should be x is f triple prime. So this will equals to 683, or A3 is equal to f triple prime and c over 6. So inputting c into the fourth derivative of f will give us c is equals to 24 A4, or we can write A4 is equal to 24 C for factorial. So let's have an example. So find the Taylor series for the function f of x is equals to ln x centered at c equals to 1. So we need to do is basically write out the first four derivatives. So the prime of x So the derivative of ln x is 1 over x. So second derivative, we need to rewrite it and use the power rule. So the second derivative is this equal to negative 1 x raised to negative 2. So f and x will be equals to negative 1 over x raised to 2. Then the third derivative, we will use the power rule again. So equals to negative 1 to x. So this will equals to f third of prime of x is equals to 2 over x cubed. So, and then to find the fourth derivative, so negative 1 times negative 2 is equals to positive 2. And then we need to take the derivative of x to the negative third, so this will be equals to negative 3 times x is the negative 4. So 4 of x is equals to 6 over x raised to 4. So to evaluate the function and the derivative at c, so f of 1 is equal, so that's going to be, so ln 1, So the natural log of 1 is equals to 0. So for the prime of f of prime x, so 1 divide 1 is equals to 1. X. Negative 1 by 1 squared. So this will be equals to negative 1. And for the f, for the prime, 2 over 1 plus 3. So this will be equal to positive 2 for the f, the prime of x. Oh, just 1. Six over 1 squared. So this will be equal to negative 6. So this is the formula that we can use. So write the expanded form of the Taylor series. So f of x is equals to f of c plus f of prime of c times x minus c raised to 1 plus f of 2 prime c times x minus c raised to 2 over 2 factorial plus f of third prime c times x minus c raised to 3 over 3 factorial. So we'll just substitute. So f of x, which is the ln x, so we can say that it's equals to f of c, which is so this will be x, and f of c is equals to 0 plus f of prime, so this 1 x minus c is equals to 1 to raise to 1 plus f of prime to c, so this will be equals to negative 1 times x minus 1 raised to 2 over factorial plus f of 3 f prime is equals to 2 x minus 1 is a 3 over 3 factorial. And 44, so 3 plus negative 6 times x minus 1 is to 4 over 4 factorial. So let's simplify. So we don't need to write the zeros here. So it will be equals to will be equals to x minus 1 divided by 1 minus x minus 1 raised to 2 divided by 2 factorial, which is simplify as 2 plus, so 2 divided by 3 factorial, so 2, so this will be cancelled. So this will be equals to x minus 1 raised to 3 divided by 3 plus, so this will be 6 divided by 4, 3 times. So this will be cancelled. So this will be equals to x minus 1 raised to 4 divided by 4. So how can we write the series using summation notation? So you can write sum is equals to the sum of 0 of 80. So when n is equals to 0, so we need to get 1 as a exponent when n is 1. Needed to get the 2, and when we need 3, and when we need 2, we will get 3. So therefore it's always 1 more than our n value. So we're gonna have the n plus 1. So n plus 1. So this is gonna be x minus 1 raised to n plus 1. So since this number are the same, so this one same, so we need to have the n plus 1 expression on the bottom. So this will equals to n plus 1. So now the last thing we need to is deal with the alternating sign. So when n is 0 for the first term, we need to get the positive sign. So positive sign. So a negative 1 to the 0 power is positive 1. So we will use the negative 1 raised to n. So here n. So this is our first